Hi, this is grade 8, chapter 9, part 1. So we're going to talk about linear relations. So Tony's Pizzeria sells medium pizzas for $9 each. It's a plain pizza, but you can order extra toppings for $1 per topping. So medium pizza, $9, extra topping, $1. So if we're going to graph this, it shows the cost of Tony's medium pizzas. It starts at $9 and it goes up by 1 every amount of topping. So on the graph, T represents the number of extra toppings, C represents the cost in dollars. So if we have 0 toppings, let's fill in this chart. The cost is $9. For 1 topping, it's 10. For 2, it's 11. For 3, it's 12. 13, 14, 15. So we know that it goes up by $1 each time. So now that we've understand, we're going to go over the table of values. So a table of values is a chart showing 2 sets of related numbers. One is going to be the X and one is going to be the Y. Now, when you do this, it's a graph. X is this way, Y is this way. So that looks like a bad Y. The Y is vertical, the X is horizontal. So remember, a table of values is a chart showing 2 sets of related numbers. That may be on your test. So make a table of values from the graph. So we're gonna work through this. Describe the patterns that you see on the graph. The cost of the baseball seems to be going up regularly, and it starts at 3. Starts at $3, or sorry, starts at $3. And goes up $3 every time. So make a table of values from the graph. So when we go here, we start with let's put number of baseballs here, and we're going to put the Y value is cost over here. So baseballs is the X value, and the Y value is the cost. So we're going to put baseballs 1, 2, 3, 4. The cost is 3, 6, 9, and 12. If we follow along, the cost of 1 baseball equals $3. The cost of 2 baseballs equals $6. 3 baseballs equals $9. And 4 baseballs equals $12. So our chart tells us how much everything costs. So if the relationship continues, what is the cost of 14 baseballs? Well, right now the relationship is B times 3 equals the cost of the baseball. So every time we have this, if we multiply it by 3, we get that. If we multiply it by 3, equals that. If we multiply it by 3, it equals that. Multiply it by 3, it equals that. So we know that if we have 14 baseballs, it's 3 times 14 equals, so 14 times 3 is 14, 30 is 42. 42, because we know that 10 times 30 is 30 and 4 times 3 is 12, so that must be equal 42. So $42 for 14 baseballs. For the next part, so if you do the show you know on 435, you should be able to do this on your own, but if you want to follow along on the video, we know that the figure number equals the first one. The number of triangles are 3. The second one, number of triangles is 6. The third one is 9. The fourth one is 12. So again, it's the figure number. So 3 times the figure equals the triangle. 3 times 99 equals the triangle. 297 equals the triangles. So this will be 297. And I hope you guys are doing this at home, because it really, really does help. So I analyzed data on a graph of linear relations. So the graph shows Nicole rate of pay based on the number of hours she has worked at her part-time jobs. Describe the patterns you see on the graph. Starts at 10 and it goes up by 10 each hour. So every hour it goes up by 10, and it starts at 10 after 1 hour. So what is Nicole's hourly rate of pay? How do you know? Well, at 1 hour, she's made $10. At 2 hours, she's made $20, because we can follow the graph. So 1 hour will tell us her hourly rate because she's worked 1 hour of work. So we know that it's $10 per hour, and it goes up consistently. So make a table of the values of the graph. We've done that on the previous one. Is it possible to have points between the ones on the graph? Explain. So can you have a point right here? I believe that you can, because you can work half an hour. So if you worked 1.5 hours, you would earn $15. It doesn't always make sense to have points in between, but when you do, you have to think about when you can. So let's go over the notes for the class, or for this lecture. So when you ask to describe a pattern, what does the graph tell me? What is the trend within the plots, and how do the plots change? So when it's asked to have plots between the ones on a graph, ask yourself, does it make sense to have other values between? So an hour, a half an hour. Yeah, that makes sense. A baseball, a half a baseball. No, you're not going to buy half a baseball. A human, a half a human. No. But if you're talking candy and half a candy, yeah, maybe you could work that. So your homework can be found at the back of the class. Thanks very much. If you have questions, please come see me.